Your browser is instructed to go to www.citibank.com, and immediately the Citibank web server gives a digital certificate to your browser. Your browser comes up with a pseudo-randomly generated symmetric key based on recent mouse movements and key presses. The browser encrypts the symmetric key with Citibank's public key, which is a field in the digital certificate. Citibank's private key decrypts the symmetric key. Now both sides have a shared secret. Your browser and the Citibank web server now use that same symmetric key to encrypt and decrypt in both directions. We've just gotten the best of both symmetric and asymmetric encryption. In other words, we now have the speed of symmetric encryption, but we haven't exposed the shared secret over an insecure medium. It was encrypted with the public key of Citibank, and Citibank is the only entity with the antidote. In fact, this is the most common usage of asymmetric encryption, not to encrypt actual data, but rather a shared symmetric secret. But wait a minute, how do we know that it is really Citibank's public key? Well, we did say that the certificate authority signed the digital certificate, but wait a minute. How do we know that the signature itself is valid? If we can validate that the CA is really the CA, and really did sign the certificate, we can feel safe and secure that the public key of Citibank really is the public key of Citibank. Of course, all this validation happens before the symmetric key is encrypted by the browser with the public key of Citibank. Here's the final piece of the story. The CA hashed the public key of Citibank and encrypted it with the CA's private key. That's a field on the digital certificate. In fact, that's the actual digital signature we've been talking about all along. Your browser retrieves the CA's digital certificate from the browser's trusted root certificate store, stored locally on your machine, and decrypts the encrypted hash with the CA's public key. Your browser also hashes Citibank's public key itself. If the two hashes match, it could only have been encrypted by the CA, because if the hash decrypts with the CA's public key, it could only have been encrypted with their private key. If the CA's private key was stolen, they would have revoked it, and it would have been all over the news. Furthermore, your browser does actually check to see if root certificates from the CA's are still valid. Now that we trust the CA is really the CA, we can trust that Citibank is really Citibank.